Naming hydrates is one of those new, not really new things. Yeah, the word hydrate hasn't really been employed before, but we're still just naming ionic compounds and then we're using molecular prefixes. This is the first of many times in this class that you'll be expected to synthesize information that you get from multiple areas. But you've got this, I promise. When naming hydrates, worry about the salt part first, because that's the hardest of our parts. Nothing has changed in our rules here, so apply what you already know. Then worry about the hydrate part. You'll use the prefixes we used in the molecular nomenclature because water is a molecule, and you'll stick hydrate behind that prefix. Formatting wise, you'll end up with a three-part name. The cation, the anion, and then the prefix and hydrate are all one word. Now let's get to it. We have the calcium cation and the chloride anion for our first one. So salt is calcium chloride. For every one formula unit of calcium chloride, there are two water molecules that are trapped in the crystal structure along with them. The prefix for 2 is di, so our third word is dihydrate. Altogether, this becomes calcium chloride dihydrate. Next up are the sodium and acetate ions, which give us sodium acetate. Here we have 3 water molecules per salt, so a trihydrate. So this becomes sodium acetate trihydrate. The last one is a type 2 compound, so you'll have to remember to include the Roman numerals when naming this cation. This gives us cobalt 2 chloride as our salt. The prefix for 6 is hexa, so that gives us hexahydrate. Our last example then is cobalt 2 chloride hexahydrate. Just like the last 3 examples, working backwards from name to formula isn't that much different than what we've done before. Barium forms 2+ cations, and hydroxide ions have a 1- charge. So we will need twice as many hydroxide ions as barium ions in order to get a neutral salt. This makes our formula BaOH2. Don't forget your parentheses. Octa is the prefix describing 8 of something, in this case 8 waters. Notice that there is not a space between the formula for the salt and the number of hydrates. The next one, we know that we have the 3+ version of iron because of the Roman numeral in the name of the cation. The phosphate anion will have a 3- charge. So these magnitudes are the same. We will only need one of each ion. Tetra is the prefix for 4, so there are 4 hydrates in this crystal structure. This gives us FePO4, 4H2O. Our last one here, which ends up looking a touch crazy once we're all done. The ammonium cation has a 1+ charge associated with it. The oxalate anion is one we won't see often, but it pops up from time to time. Its formula is C2O4 2-. We won't include a number in front of the hydrate here because there's only one of them. If you see mono, know that your 1 will be implied. Make sure your ammoniums are in parentheses, and you should end up with NH4 2 C2O4 H2O.